The next example basically says to prove the following statement directly from the definitions of the terms. So we cannot use any previous theorems or corollaries to do this problem. We have to go off the definition of the term's rational number. It says, for all rational numbers R and S, if S is not equal to 0, then the fraction 2R divided by 5S is a rational number. This would be a good practice for you to stop the video right now and see if you can prove this. As a matter of fact, this problem has been on tests in previous semesters. So this is kind of the level that I expect from you on the test. By the way, this statement is a true statement. See if you can try to prove it. Pause the video and give it a shot. To prove the statement, I'm going to begin with two numbers R and S that are rational. I'm choosing the R and S because that's the variables that they picked in their statement. Furthermore, I want S to be non-zero. This was given to me by the theorem. They told me to pick the second number to not be 0. So I'm allowed to make this consideration. And I want to show that 2R divided by 5S is a rational number. That's the goal of the problem. Now, since both R and S are rational numbers, and S is not equal to 0, then by definition of rational number, I can say the following. I can say that there exists A, B, C, D that are integers, where R is equal to A over B and C over D is equal to S. Now keep in mind that B and D are automatically not equal to 0 because of the rational definition, because R and S are rational numbers. But I'm also adding an extra little letter over here called C, and I'm saying C is not equal to 0. Why can I make this assumption? Well, I can make this assumption because S is chosen to be not equal to 0. So for S to be non-zero, it means that the numerator, C, has to be different than 0. So that's the reason why you're seeing an extra letter on this line. Now, if I consider the quantity 2R divided by 5S, then it can be written as 2 times A over B divided by 5 times C over D. This is automatically by direct substitution. And if I multiply the fractions and divide them out, I'm going to end up with 2AD all divided by 5BC. So all I'm doing here is using the algebra of fractions, and division of fractions turns into multiplication of the first one times the reciprocal of the second one. So that's what happened on this step. But now recall that A, B, C, D are all integers, and also B, C, and D themselves are not equal to 0. So what does that mean? That means that the numerator is an integer, the denominator is also an integer. And also, since B and C are separately not equal to 0, then 5BC is also not going to be equal to 0 either. So I'm recording that so that the reader can see this. So what does this mean? This means that 2R divided by 5S is the quotient, quotient means it's a fraction, of an integer divided by a second integer, where the second one is not equal to 0. So that means that 2R over 5S is exactly a rational number, and that's what we wanted to show.